Salim sir?
Shall we start, Fawzan?
Yes, sir. Yes.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Yes.
I request Janab Syed Salim sir to start the program with the Qiraat.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إذا جاء نصر الله والفتح ورأيت الناس يدخلون في دين الله أفواجا فسبح بحمد ربك واستغفره إنه كان توابا صدق الله العلي العظيم.
Jazakallah khair, Syed sir. Respected Auzubillahi minash shaitanir rajim. Bismillahir rahmanir rahim. Respected speaker of the day, Mrs. Shameem Raja. Janab Nasir Bhai. Dear teachers, Assalamu alaikum wa rahmatullahi wa barakatuhu. Umiyat is an organization of Muslim educational institutions of Tamil Nadu. Umiyat strives to bring quality in education through various initiatives, including teacher trainings, webinars, science fairs, early goal setting programs for 9 to 12 students to enable them to take up UPSC exams, and many such initiatives. For the past 14 years, we have been conducting science fairs for students, school students. This year, it is unique that we are including students throughout India with the collaboration of AMP, or Association of Muslim Professionals. On behalf of Umiyat, I am delighted to welcome one and all for this webinar to be delivered by Janaba Mrs. Shameem Raja, Principal, Ar-Rahman International School, Melur. And the topic for today is Scientific Methodology of Science Fair Projects, Preparation of Physical Science Projects. Mrs. Shameem Raja is a MSc in Physical Science. She is a B.Ed and she is pursuing her M.Ed, and also she is pursuing her PhD. She is a principal of Ar-Rahman International Schools. She has been there for 9 years now, and her area of interest is science and all innovative methodologies of teaching. She has trained teachers to guide the students in research. She has conducted 13 webinars, including project-based learning. She has published 3 articles, one on project-based learning, one on need of paradigm shift in elementary science, and the third one in best teaching practices, which has been published in Usmania University. So today she will be talking to us about the methodologies to be followed in science fair. Over to you, Mrs. Shameem Raja.
Thank you, ma'am. Kindly please allow me to share my screen.
Fazal?
Yes, ma'am. I will do.
Yeah, thank you. Ma'am, have you started speaking? We can't hear you.
My screen is visible, ma'am?
Yeah. Now you are audible, ma'am.
Yeah, fine. Thank you, ma'am.
Thank you.
Yeah, good evening, all of you. In this wonderful evening, I would like to take this opportunity to share with you all about the scientific research methodology and how to prepare the students regarding the physical science projects. Coming first, I want to share one important point here. Nations are progressed in the field of science and technology have always prospered and played an important role of leadership in the world. This is the lesson we learn from our history. I hope everyone agree with the statement. Yes. Science and technology always brighten the nation's progress. See, as teachers, what is our part in that? See, we are dealing with the future nation builders, the students. So we must think over it. And this session will help you to explore your part in brightening the nation's progress. See, first, I talked about teachers here, but the science teachers are really very special because they are the one who can have a lot of opportunity to develop the science and technology spirit among the students through their classes. Within the classroom, they can do n number of activities through which they can sparkle the scientific spirit among our young scientists. But actually, what is the problem with the science teaching? Do you think all our science classes are taken in a proper way? We have to think over it. Most of our science classes are being taken as language classes. They are explaining the ready-made facts that has been given in the textbook, and they're preparing the students only for scoring marks in their examination. They're spoon-feeding every points. They are not allowing the students to think. Rather, they are making the students to memorizing the ready-made facts in the textbook. Do you agree with me? As 21st century teachers, we need to feed the science process skills among our students. I want to share the science process skills with all of you. See, these are the some science process skills which we science teachers must know. The first thing is the observing skill, which leads the students towards the scientific methodology. Okay, and then inferring is the most important skill we need to develop among the students. See, based on the observation, the child may infer something. And the third process skill is the measuring skill, measuring the quantity, measuring the quality. That is very important for them. There are we must use in our syllabus. We used to teach a lot of physical measurements to the students. In addition to that, they should know how to measure the exact values with proper measuring instruments. And communicating, it is a very important skill. They must know how to communicate what they learned. And classifying skill, that classifying skill is highly important. Excuse me. Uh, 2 minutes, please.
Okay, okay.
Yeah, okay. Classifying it is nothing but grouping or ordering the objects or the events into some categories, that too based on the properties or some criteria. For example, placing all the rocks having a certain grain size or hardness into one group. And the last one is the predicting, which plays a major role in the scientific methodology too. So in prediction, it is nothing but a guess, an educated guess about what might happen in the future. So these are the are the science process skills we science teacher must know, and we must enrich these science process skills among our students through our classes, through the way we take the class. Then comes the science fair. The science fair is a major tool which we can use to enrich all the science process skills. Through this one tool, we can enrich all the science process skills. Let us see how. Can you guess what is the difference between these two majors? Any guess? What are the differences you can observe in these two majors? In the left
Electricity generated through lemon.
electricity generated through lemon. Okay.
The
In the left
blowing
side,
of
yeah, please come again.
blowing of bulb we can see because of citric acid present in lemon.
Yeah. The difference between these two right side and left side image.
Left side we are just observing the bulb is glowing, ma'am. Right hand side we are we are measuring the how much amount of current is being generated.
Yeah, this is the major difference
Using
between
multimeter.
the exhibition and the science fair. See, science fair is one of the important tools and which help us to enrich all the science process skills we said, right? In the left side, a lemon battery model is just built. But in the right side, there is a setup for some experiment, right? This is where the science fair projects differ from the science exhibition models. See, in science exhibition, curiosity doesn't play any role. It is just a display of already established facts and results. Students just copy the steps and imitate, that's all. But in the case of science fair, here the projects are curiosity driven. Data has been collected through the experimentation to find the results, so which are not known before. Here students use their own creative method to find out the results. So in a science exhibition, they do not have any element of research. Whereas in the science fair, the research-based activity in which we plan and design an experiment is required here. So that's why we want all the science teachers to encourage the students to participate in the science fair, not in the science exhibition. So, in many schools, exhibition, we had seen the display of lungs, windmill, volcano, and many such models. But in all those, again, they just they didn't test anything. They just exhibit. Here, just the students build the models. There is no space for creativity and innovation. But in the experiment, the student tests something, and the student found, and they collect some data. Based on the data, they will present some results. They found new thing through the experiment. We know kids love to play. Obviously, kids love experiments too. So here, okay. So what type of projects we should do for the science fair? So you have to do a project which always emphasizes on using the scientific research methodology. See, which is the way the real scientist works in the science labs. See, projects which allow investigation by experimentation and develops the critical thinking skill of the students. And those projects which give the opportunity to the students to build a positive learning experience, which is the need of hour. See, while the science fair project is entirely the product of students' creativity work, motivation and guidance from the teachers is really invaluable. So the science teachers are not only teachers here, but also you are the research scholars. So as teachers, as research scholars, you should understand clearly first what exactly the scientific methodology is. So it is a research method in which a problem is identified, relevant data is gathered, and the hypothesis is formulated from these data, and the hypothesis is being tested. So we will see the scientific methodology steps one by one in detail, which will be highly helpful for you to guide your students how to do a project using a real scientific method. The first step in the scientific research method is the observation. This is the basics. So under observation, we always use our 5 senses for observation, right? We use our eyes, skin, ear, tongue to sense objects, right? So using our 5 senses, we observe. So this observation leads to the problem question. See, this is very important if you are doing a science fair project, because always you want your project to be focused on something that will hold your attention, something that you are interested, right? Without interest, we can't observe things. So your interest kindles you to observe things, observe new things, and try and ask you to find out, try to find out for the answers. This is where you come up with the idea for your science project. So the second step is the questioning step. So once you have made your observation, you must formulate a question or a problem about what you have observed. See, your question tells what it is that you are trying to discover, that what you are trying to find out. See, while stating your question, you should be very specific as possible. For example, if you are doing a project about plants, your question must be specific, like, do the plant species inhibit bacterial growth? Does a plant grow better in direct or indirect sunlight? Does the amount of sunlight in plants gets affect how it grows? So you have to frame, you must frame your question or your problem statement in this way. You can frame your questions in any of these formats according to the problem. For example, what is the effect of sunlight on the growth of plants? What is the effect of eye color on the pupil dilation? What is the effect of grains of soda on a piece of meat? What is the effect of this on this? Like that, we can frame the question. And how does affect type of question? So how does the color of light affect the growth of plants? How does the color of material affect its absorption of heat? And which and what work question. So which paper towel is most absorbent? What food do we moms prefer? Like that, these are some samples, some format, how you can frame your question or problem statement for doing your scientific research. See, then the next step is the background research. See, you have to research about your problem as much as possible. See, you have to become like an expert at what the real scientists do in real labs. So first you have to read about your topic. You can read the encyclopedia, read magazines, articles, books from the library, articles, and while reading, you have to take notes. Like the same, you have to encourage your students also to take notes while reading from different articles. Second thing, you may discuss with the peers, parents, and some professors, some subject matter experts, doctors, veterinarians, based on the topic. But make sure to take photographs while having discussion with some professionals. It may be a proof for your projects. And next step is framing the hypothesis. So hypothesis is nothing but it is an educated guess, a smart guess, prediction. So predict what will happen. So we must record the hypothesis before you start doing an experiment. But please make sure we should not change the hypothesis. First, after framing the hypothesis, we will do some step and we'll find out whether the hypothesis is right or wrong. So even the hypothesis is wrong, you should not change the hypothesis. Keep the hypothesis same. At the end, we may tell that our hypothesis is proven false. Like that, we can prove. Here, I framed one hypothesis example that the plants grows better under indirect sunlight. we will see how we can write the hypothesis. As we all know, for a building thing, the blocks, each and every block is important. Like that, a hypothesis is a act as a building block in the scientific method. It is a highly important for a scientific research methodology. So it must be always written in present tense. No past form is used here. It's allowed to use here. We all know that the question comes first. For that question, we will predict what might happen, right? So hypothesis must be always a statement and not like a question. You must clearly state the hypothesis. While defining the hypothesis, keep the variables in your mind. Later we will see what is variables in detail. There are two types of variables. You must include the independent variable and dependent variable in your hypothesis statement. The most important thing here you must think is, you must make sure that your hypothesis is testable. So you must narrow down your project. So you must frame the hypothesis in such a way that we can test and we can find out what may be the solution. So here are some examples for the hypothesis. I think the car on 8 centimeter high ramp will travel the farthest distance from the end of the ramp. Second, I think the ice cube with the least amount of salt will freeze in the shortest period of time. See here, these two examples shows that this is the guess. The student or the teacher is made this guess. Okay, so you frame the hypothesis. The next step is we have to design an experiment. Experiment to check whether the hypothesis is true or false. See, while planning an experiment, you must think about the variables. The variables are highly important here. Let us see some more examples for the variables too. See, while framing the experiment, while planning your experiment, you must design the step-by-step procedure to test your hypothesis. So the experiment should be always a fact test, in which you can use only one way. You can change only one variable at a time. Just a minute, please. While keeping the everything same. See, this makes your experiment a controlled one. You have to include a specific way how to measure the thing.
Ma'am, you are in mute, ma'am.
We can't hear anything.
Yeah.
We are not able to hear anything.
Yeah, ma'am. Yes. Here, see, these are the different types of variables we must consider while planning an experiment. These variables are independent variable, dependent variable, and controlled variable. Here, independent variable are nothing but the factors or such conditions that we manipulate in an experiment. See, your hypothesis is that the variable causes a direct effect on the dependent variable. So there can be only one independent variable in an experiment. See, this is one which we intentionally change in the experiment. Dependent variable, these are the factors that you observe or measure. Based on the independent variable, the dependent variable will change. There can be one or more dependent variable in an experiment. Then the last is the controlled variables. This is a factor or the condition that we keep constant throughout the experiment. There may be many controlled variables in an experiment. We will see some more examples for this. See here in this experiment, the amount of water you pour is the independent variable, which we intentionally change. And the height of the plant growth is the dependent variable, which depends upon the independent variable. So the soil, the pot, the amount of sunlight here are the controlled variables for this experiment. Like the same in this experiment, the problem statement is how light affects the plant growth. Here the independent variable is sunlight, because this is the one we are intentionally changing, the amount of sunlight. Based on the amount of sunlight, the height of the plant will change. So that is the dependent variable here. We must have one set of experimental group in which no treatment of the independent variable must not be there. So that is the controlled variable, controlled group in this experiment. So for a fair science fair project, one control group is very important, in which the independent variable does not make any effect on it. And here in this experiment, the fertilizer, see the amount of fertilizer or the type of fertilizer is the one which we are intentionally changing. So here the fertilizer is the independent variable, and again the height of the plant is the dependent variable. The pot, the soil, the amount of sunlight, water, everything must be controlled for this experiment. Same thing here. Does the red light affect plant growth? Here the color of light is what we are changing. So the light color is the independent variable here. The height, the plant height is the dependent variable here. Water, soil, temperature, and the time. These are the control variables for this experiment. Now I want the participants to give a try. For each of these experiment, I want you to specify the independent variable, dependent variable, controlled group, or any other constant. See, this is a very important while designing the experiment, because even while framing the hypothesis, we have to include both the independent variable and dependent variable. So we must know how to identify the variables in our project. I want the participants to please find out, to tell me the answers for them. The first one, a student want to test how the mass of paper airplane affect the distance it could fly. Paper clips were added before each test flight. As each paper clip was added, the plane was tested to determine how far it would fly. For this experiment, what could be the independent variable, dependent variable, and control? You can talk or you can chat. Participants,
For the first one, I think, ma'am.
sorry.
For first question,
Okay.
Independent variable is adding.
Excuse me one minute.
Adding the paper clips. Hello. Am I not audible, ma'am?
You are audible, ma'am. What happened to ma'am? Shameem, ma'am, you are not audible.
Yes. Yes. Here the independent variable is the paper clip.
Yes.
The number of paper clips we are intentionally changing. That is the independent variable, and based on the number of paper clip, the distance will vary.
And control is mass of the paper.
Yeah, paper airplane. Again, it is the mass of the paper or the type of the paper we intend to use. That
Yes.
must be same. Yeah, like the same second, two groups of students were tested to compare their speed working math problems, and each group was given the same problems. One group used calculators and other group computed without calculators. For this project, what may be the independent, dependent, and controlled variable?
Dependent is calculator.
Sorry?
Dependent is calculator.
Yeah.
Independent is without calculator.
Groups of students were tested.
Okay. Yes, the independent variable is calculators. The dependent variable is the speed of calculation. And the controlled variable is the problem. The same problem must be given to both the groups. Do you agree with these two type of variables examples?
Yes, ma'am.
Do you have any doubts in that?
No, ma'am, no doubts.
Yeah, fine. See, the most important thing, we should know what is a fair test, because our science fair project must be a fair test. Okay. See, here. See, you have to conduct a fair test by making sure that you have to change only one factor at a time and keeping all the other remain conditions as the same. For example, if you are testing the toy cars on the ramps, okay, toy cars on the ramps, and you change both the inclination of the ramp and the surface of the ramp, the test would no longer be fair. We can't predict whether the changes are made because of the inclination of the ramp or the surface of the ramp. You could no longer be confident that the ramp or the incline alone was affecting the distance travel, right? So the new type of surface may cause the car to roll with less friction, and hence it could affect the distance travel. So you must change only one variable at a time. That is very important. And also you have to do multiple trials. We can make sure that our results are consistent and not altered by the random events. See, multiple trials can be done one at a time. If we were testing with a new fertilizer, we could test it on lots of individual plants at the same time. Also, sampling plays a major role. We have to be very careful on selecting the samples because it determines the accuracy of your research. That is your result. If anything goes wrong with your sample, then it will be directly reflect in your final result. For example, if you are planning to do a project using a fruits, don't buy a single fruit for your experiment. That may be defective. So you have to buy few more many fruits, and you have to select a good samples among the fruits. Also, if you are testing the lung capacities in a group of smokers, non-smokers, it is very essential for you to collect data by testing large number of group people. This will improve the precision and accuracy, which better improve the outcome of your experiment. And repeating the experiment and collecting the data multiple times and increasing the sample size, these three reduces the margin of error and improves the confidence interval in our science fair project. So after planning the experiment, you must ready with the materials and follow the steps you designed for your experiment. See, observe and measure the variables very carefully with the control. See, design a chart priorly that includes what you will change and what you will measure. See, the data chart is a place to record your observation or the measurements. See, keep all the data recorded in the notebook or in a project journal. It is very important proof that you actually did the project. See, during the presentation and the interview time, the judges will want to see this work. And you have to test your hypothesis through your procedure of experiment, and you have to analyze your data. So always use metric measures like centimeters, grams, and millimeters. This will be highly effective in your project. And then a science journal, you must keep your science journal. See, it is like a science diary that you have to keep throughout your experiment. In your journal, you can record your observation, you may collect the information, and you can draw pictures, flow charts. You can jot on many additional questions. You must include each and everything you did for this project from the beginning till the end. This logbook is a proof. This science journal is a logbook, which is a proof that all the activities has been conducted by the students itself. Here I had given some examples for the log entries. See, the date has been given, and under the date, what activities has been done by the students, that has been clearly noted. Some more examples. So while doing the background research, you may encourage the students to note down what they learned from that encyclopedia, from the Google, from the magazines, from the interview. We must encourage the students to note down each and every point. And while collecting the data also, it is very important to write all those data in the science logbook. Okay, then this step is the analyzing the result step. Under result, it includes data and analysis. So we have to organize the data in the form of charts or tables or graphs so that it gives a quick and easy interpretation. See, in the bar graph, the results are so self-evident and very clear. See, while plotting the graph, the most important thing to be noted is you have to plot the independent variable in the x-axis and the dependent variable in the y-axis. This is very important thing to note. And conclusion, it is a brief summary of what you have discovered based on your experimental results. So you have to analyze the data you collected and you have to summarize the results in the written format. And you have to analyze to answer your original question. You have to do the result of your experiment, support or oppose your hypothesis. So state your findings in relationship with one variable with the other. What changes has been made. Do not change the hypothesis if your results are not what you expected. So you may find the results of your project in such a way, you may write whatever you found based on the variables, you may conclude the thing. Okay, you may give reasons. Why do you think the result did not support your hypothesis? Try to find out why. Then the next step is to present your findings in a most appropriate way in research report format and also using the display board format. So now we are done with the scientific method. So these are the steps you must encourage the students to do a proper science fair using the scientific research methodology. So we will see an example project, a physical science example project here. See, magnets. We know about magnets, right? We are using magnets in our day-to-day life. Magnets are used in the hard drives to store the data in our computer, the speakers in our headphones, which are powered by the magnets, and our refrigerator, our door handle, everything we are using magnets. But the magnets can only operate within a certain temperature range, right? See, by observing this application of magnet in our daily life, there comes a question. Which magnet is more temperature resistant? This is a problem statement for this project. And for this problem statement, you may encourage your students to do a background research By doing the background research, the hypothesis, the educated guessed the prediction here is ferrite magnet is more temperature resistance than neodymium magnet. See, there are many type of magnet. Always we must narrow down our project. So here in this project, ferrite magnet and neodymium magnet alone is taken for research. And to test the hypothesis, an experimental procedure was designed, and the type of magnets here used is neodymium and ferrite magnet, and these are the types of magnet we are intentionally changing, and this is the independent variable here. And based on the type of magnet, the magnetic strength will vary. So here the magnetic strength is the dependent variable, and the temperature and the weight of the paper clip, everything is the controlled variable here. And these are the materials used for conducting this experiment: magnets, thermometer, plastic tongs, refrigerator, water, ice cubes, a strong bowl, pot, induction stove, digital weighing machine, and paper clips. See, to study and compare the temperature dependence of both the magnet and to find out which magnet has a more temperature resistant, the tests were done using both the magnets by treating them under room temperature, that is 33 degrees Celsius, and freezer temperature 4 degrees Celsius, and at ice water bath 9 degrees Celsius, and boiling water bath of about 90 degrees Celsius. See, the magnetic strength is calculated, was being planned to calculated using the amount of paper clips that the magnet was able to collect at each temperature. So this is the step-by-step procedure designed to test the hypothesis. And these are the data charts designed to record the data. So in this data charts, again, both the type of magnet, both the variables are mentioned here. And also in this data table also, many trials are included, which increases the accuracy of the result. And these were the observed data for the project. For this observed data, average has been taken for different trials. First table shows the room temperature measurement, and second table shows the freezer test, third ice water bath test for both the magnet and boiling water test, and the fifth table is the comparison table for both the magnets magnetic strength, and the final table is again a comparative table which will be highly helpful for to come out with the result. This is how the data table has been designed, and the data has been collected, and the data has been analyzed. And this is a graphical representation which shows the comparison of the temperature resistance between the neodymium and ferrite magnets. See, here data were analyzed and the results were formulated. Neodymium magnet, it attracts many paper clips than the ferrite magnet of the same dimension at this temperature that has been planned to test. It shows that the magnetic strength of the neodymium magnet is higher than the ferrite magnet. The variation in the loss of magnetic strength was high at the boiling water test temperature than the freezer temperature. So when exposed to the boiling water test, neodymium lost more magnetic strength than the ferrite magnet. This has been found by doing this experiment. And based on the result, we need to conclude the things. This research showed that even though the magnetic strength is higher in the neodymium magnet than the ferrite, it lost more magnetic strength when treated under the extreme temperature. That has been found through this experiment. So here the ferrite magnet is most temperature resistance than the neodymium magnet. So again comes the hypothesis. Previously, the hypothesis stated is ferrite magnet is more temperature resistant than neodymium magnet. That has been proven true through this experiment. I hope now everyone understood the steps in the scientific research methodology. Now it's a time to trigger your students to do a science fair project. So as research scholars, you should help your students to choose a topic under their interested category. See, science fair project, it allows the students to investigate a question of interest to the student. So all the great projects, they start with great questions, but before that, the students start with a question that, and so please encourage your students to choose a topic based on his interest. The student might be curious about different types of birds that visit a backyard bird feeder. So he may decide to investigate whether using different types of bird seed will attract the different type of birds. So based on his interest, he may select the project. So please make sure don't copy the project from the internet. Don't try to find answers for the already established fact, or don't try to prove already proven fact. It must be innovative. For example, aluminum has a high corrosion resistance than iron, right? It is proven already. Don't try to prove the same in your research. See, even if you follow the scientific method for these type of experiments, it will not be considered for selection. So your project must be original in content and should be verified with the data collected from the experimentation. Your project must be new and innovative. So guide your students to choose the title that reflects the topic, and it must be in the form of a question. And next step you have to do is make your student clear with the purpose of the project. Ask them to describe in 1 or 2 sentences about why they intend to do that, why they intend to do this project. And then guide them with the resources like books, magazines, since they are a primary and upper primary, secondary students, right? You may guide them which resource can be better for them to get more deeper knowledge about their selected topic. So guide them using by referring some books, magazines, websites. So help them how to do a deep background research. And next, ask the students to make an educated guess about how do they think their experiment will turn out based on the background research they done. And then students need a proper guidance to design the experiment step by step. See, otherwise, all the upcoming steps will become vain. So because it is very important for them to clearly define the step-by-step process, right? So experiment must be designed so that they only test for one thing and make sure that they do not do the same things to all the group of objects being tested. So you must check whether the variables are stated properly. For example, if they are going to test some plants, they have to use the same seeds. They have to plant all of them with the same soil. They have to put all of them in the same amount, under the same amount of light for the same amount of time. The only thing they should change is the amount of the received coffee or the other water. What they want to check, which factor is affecting the rate of growth. That factor alone they have to change. The remaining all the factors must be used in the same way. And we must encourage the students to increase the validity of their experiment. They must sure to keep a control group. Control group will be highly helpful for us to compare the experimental group result with the control group result. Okay, so they must be encouraged to keep the sample size. They must include more samples, and also they have to use multiple trials. And also you have to guide them in choosing the material. So for example, if a student plan to measure the intensity of the light, guide them with the proper apparatus which will be helpful to measure the intensity like lux meter. Sometimes there may be possibility to search for another alternative apparatus due to the non-availability or the cost. In that case, help them to take the proper measurement. Okay. Procedure, and also the students to write the step-by-step procedure and ensure they do not leave any step. And now it is the experimental part. There's a fun part of the science fair experiment. Motivate the students to do the experiment in a very safe and secure way and make them to enjoy experiment. So guide them to display the data collected using the charts, tables, and graphs. Teach them the proper way of representing the collected data. There are different type of graphs according to the project selected by the student, according to the data collected. Encourage them to present the data using the graph or pictures. And help them to present their results based on the data collected. Help them how to analyze the data properly, and based on the analyzed data, ask them to come out with the results. And based on the results, ask them to write the conclusion. Check whether their hypothesis has been supported or not. If it is supported, then it is fine. If the hypothesis has not been supported, ask them to tell the reason why the hypothesis has not been supported. Ask them to explain the reason for that. And encourage the students to add future consideration based on the experiment that the student has been selected. See, according to their grade level, initially they will do one project. When they move on to the next grade, you may encourage the students to improvise the same project in a broader way. The next thing, after once the project has been completed, we have to prepare our display board, which will be highly helpful for us to present our project to our judges. The display board must be very clear, and there are certain rules and regulations to be followed while preparing the display board, because display board in the display board you have to paste all the things that you done in the project in a more precise way. So it must be readable. So you may prepare a trifold display board like this, in which center you can write the title. You must prepare your display board in such a way the judges or the audience, they must read from the left top to the right end. So we have to write the purpose, hypothesis, the materials you used, and in the middle of the display board, you may present the charts, the data you collected, and you can represent the data in a graphical way, and your results and your conclusion and the future consideration you can write at the right side. And in front of the display board, you have to present your research report and the data book, that is nothing but the log book. You have to keep the log book in front of your display board. In Google, you may find different examples how to make display board for your science fair project. Here I presented few examples, few samples. See, until this time we learned the scientific methodology, right? You may wonder how we may make the student to practice the scientific research methodology. So here I would like to share one of the method that we are using in our school. See, from 4th grade onwards, we introduced a topic, Think Like a Scientist, through which we try to introduce the scientific methodology to our young students. I will share the document with you. So this is the document. Is the document visible? See, I hope most of you know are aware of the 5E method of teaching science. It is highly recommended by National Science Teachers Association for teaching the proper way of teaching science. So under the 5E method, we created our own lesson plan to enrich the scientific research methodology among the students. So first, for 4th and 5th students, we are introducing the science process skills. We are giving individual practice to the students, how to observe, how to infer, how to predict, how to classify, how to measure the things. So first we are encouraging the teachers to engage the students towards the topic by asking some questions. What do you think when I say scientist? How can we think like a scientist? So the teacher may brainstorm the ideas from the students. And the second step is the exploring step. The teacher may encourage the students to explore by showing a particular picture. First, by showing this picture, the teacher may ask, list the 3 observations from the given picture. Second, the teacher may kindle the inferring skill through using your observation, make some inference about what has happened. And third, the teacher may ask to predict what will happen next. On what evidence will you use to make the inference? So, we may wonder, many students will come out with a very different answers. Here, there is no right or wrong answers, right? We may encourage the students through one activity. We are making the student to observe, infer, and predict. And then the teachers are asked to explain what is the scientific method, the step-by-step scientific methodology, and the history, the scientific method, everything the teacher need to explain. Yeah, with more examples. And the teacher may, under elaborate session, is the 4th session. The first is the engage, second is the explore session, third is the explaining session, and 4th is the elaborate session. Under this session, the teacher may give worksheets to the students to apply what they learned in the previous session. So a simple experiment, the teacher may give to the students and ask them to come out with some data to check whether the hypothesis is right or wrong. So this worksheet will be highly helpful for the students, how to frame the hypothesis, how to check the hypothesis, how to prove whether the hypothesis is true or false. And then again, some more worksheets too. And then the evaluation part, the final part, because as teachers, once we complete each and every topic, we will evaluate, we will assess the students' knowledge in that particular topic, right? Like that, some assessment for assessing this topic, we added a few questions. And the worksheet. So under 4th and 5th level, this will be highly helpful for the students to approach a problem or a statement step by step using the proper scientific research method. See, first, you must allow the students to ask a question and make a prediction and make a plan, and then observe and then record the results, and then to draw the conclusion. Excuse me. So for 6th and above, this is the one we are following. Some more different way, but the methodology, steps, everything is same. The complexity level will vary here. So through this chapter, we are introducing the scientific research methodology to our primary and upper primary students. Once they got familiarized with these scientific methodology steps, and then we may encourage them to come out with a project idea based on their interest, and the teacher must guide the students throughout the experiment to find out the result and to complete the science fair project entirely. So this is the one we will give. So this is what we prepared. And also for the higher grades, we can give this type of worksheet for the students to come out with a scientific project. Some space at the beginning level, because we must make the students familiarized with each step, right? So we may provide a worksheet like this. It may be highly helpful for the students to go step by step, and they don't miss any step in the projects in following the scientific research methodology. So that's all about the science research methodology. So this is the sayings, Quasi sir. I hope many of you know about him. He always used to say no to science exhibition and yes to science fair. But the most important thing I would like to share is don't prepare the students only for participating in the science fair. Let them start the research work in their own interested area. Please help the students to develop the ability to analyze and solve the problems. See, develop the science inquiry skills. We must teach the students to take the failures as learning, and there must be perseverance in their work. You must develop the capacity of the students to transfer the skills over the various fields. That is the STEM integrated coaching. We must make the students to be more creative and innovative, thereby think and act like a scientist. I hope this session will be an eye-opening session for you all regarding a science research methodology. Thanks for your valuable time. Thank you all.
Thank you, Mrs. Shameem Raja, for a wonderful and very clear speech. And very patiently you explained each and every aspect of the scientific methodology. We will take some questions if there are any. We'll take some questions. If you have questions, you can please ask, unmute and ask.